Hello everyone, I am Abhishek Paudel. Today I am going to do a numerical which is from chapter number 7, Energy and Momentum Principle Hydraulics. Okay, I have taken a numerical from K. Subramanian, a very popular book in Open Channel. You can go through that question if you want. Okay, this is a case, I have taken the case of with constriction case. Okay, I have taken the case of with constriction only. I dealt with the problem in which there was hump case only and combined hump in with constriction case. Okay, so but this question is particularly with constriction case only. Okay, you can go through the question. A rectangular channel which is 3.5 meter wide, conveys discharge of 15 meter per second. Okay, so this is the case in which it is proposed to reduce the width of the channel. Only width of the channel. It is proposed to reduce the width of the channel only. There is no hump case like before. Okay, there is no hump at all. But in the past lectures, I told you that let's depict this as a hump. In past problems, we dealt with by comparing the energy at section 2. Let's say this is the energy E2 and this is energy E1. Okay, E1. So, so before starting the numerical, you must understand that what to do in this type of problem. In this type, you have been calculating energy at the section 2. You have been calculating the energy at section 2, E2, and compare it with what? Compare it with what? EC2. You also calculate the critical energy at section 2 and compare it in order to assign that the flow occurs or not, or choking occurs or not. We have been doing this, okay? But when E2 is greater than EC2, flow occurs, okay? There is sufficient energy at section 2. There is sufficient energy at section 2 to flow, okay? But in this type of with constriction case, we go through with constricted. We compare the constricted with critical width. Okay, so minimum width. Okay, let's understand whether the flow occurs or not in the case of with constriction. Only case. In this problem, when B2 is greater than B2 minimum, we must calculate B2 minimum here. B2 is greater than equal to B2 minimum. What happens? No choking occurs. No choking occurs. When B2 is greater than B2 minimum, no choking occurs. But when B2 is less than B2 minimum, choking occurs. No choking occurs mean flow is possible. Choking occurs mean flow is not possible. Okay? When the flow is not possible, then there must be additional energy from the upstream. There must be energy, the energy must be added from the upstream. Okay? So, let's proceed to the question. Okay? You understood here? When the B2 is greater than equal to B2 minimum, no choking occurs. Flow is possible. If B2 is less than B2 minimum, choking occurs. If it is less, choking occurs. We go through like this. We go like this, okay? Not from the energy comparison. We go from constricted width comparison, okay? With minimum width at section 2. Okay, now let's write the data from the question. I am going to write the data here, given data. Okay, you can write the given data here. Before writing this, I am going to take the first case. Okay, we can go through the cases later. First of all, we write the data and we enter into the cases. Okay, given data. Given data means a rectangular channel is 3.5 meter wide. B is equal to 3.5 meter wide and conveys a discharge of 15 meter cube per second. Discharge of 15 meter cube per second. 15 meter cube per second. At a depth of 2 meter, y is equal to 2 meter. It is proposed to reduce the width of the channel at a hydraulic structure. The width has been reduced. Okay, the width has been reduced we go through later on. So given data, there the width has been reduced here, so that's why you have to term this as B1, because we are going to draw a picture like this. Here there is a width is constricted, okay, width is constricted here. This is a width constriction case only. You can draw the picture like this, 2 2, and you can draw the picture like this, 1 1. Okay, this is upstream and this is downstream. Let's denote the upstream suffix is 1 and downstream is 2. In this case, this is a case in which we check the constricted width with minimum width. Okay, so this is section 1 and this is section 2. There is a width constriction is occurring, so that's why you have to write here B1. Okay, B1, you have to write B1. If there was no width constriction, if there had been no width constriction, you would have written B1, B only, but in this case you have to write B1. Okay, just like B1, you have to write Y1. Y1 is upstream depth Y1, and there is a downstream there. You have to calculate the downstream depth Y2. Okay, so question asks you to determine the water surface elevation, means that is the depth of water surface. Okay, now let's proceed to the question. We have written here B1 3.5 meter, and then width have been reduced to 2.5 meter. And now this is Y1, and there is another depth Y2, where there is a constricted width, there is a change in water surface elevation. Okay, now let's proceed. I'm going to erase this question. So because of the limited space here, I'll erase the question and okay, now let's find out. Let's stay on the upstream. Okay, upstream means I'm going to draw a picture again here. The picture is like this with constricted case, and there is a 2 2, and there is a 1 1, and there is a B1, and there is a B2. Okay, so let's stay on the upstream. Upstream means 1 1. 1 1, upstream means 1 1. Okay, upstream, let's calculate the velocity. Okay, v1 is equal to q by a1. You know continuity here, q by a1, and q given here a1 b into y1, b1 into y1, because there is a b1 upstream, there is a b1 into y1 is also given, b1 is also given. Okay, q how much? 15 divided by b1 how much? 3.5 into y1 how much? 2, and you will get what? You will get the velocity is 2.143 meter per second. 2.143 meter per second. Now let's calculate E1. E1 means y1 plus b1 square divided by 2z. y1 is how much? 2 plus b1 is how much? 2.143 square divided by 2 into 9.81, and you find the energy E1 how much? 2.234 meter. 2.234 meter. Okay, write it in your copy. 2.234 meter. This is the energy at the upstream. This energy is called as specific energy. In open channel flow, we term the energy in terms of specific energy. Energy taken with respect to channel bottom. Okay, not the datum. Okay, energy taken with respect to channel bottom. So we deal with the energy, specific energy. This is called specific energy. Okay. So this is E1. We have completed the upstream calculations. Now let's go to the section number 2. Okay, downstream. You note it in a copy 2 2. Let's go to downstream. Let's go to downstream and find the value of minimum width. Okay, B2M. Find B2M. Find B2M so that we can check whether the flow is possible or not. Okay, find B2M so that we can check whether the flow is possible or not. So to find B2M, we can apply the energy equation between 1 and 2. Okay, let's apply energy equation. Let's apply energy equation between 1 and 1 to 2. Okay, let's write 1 first. E1 is equal to ECM. Okay, I'm going to find out the B2M here. E1 is equal to ECM. ECM, okay. So because there is no hump, the energy at the constricted is equal because there is a frictionless. Okay, you can equal the energy at 1 and 2. Okay, there is a very frictionless with constriction case. So that's why there is loss is very negligible. So that's why you can write E1 is equal to ECM. Okay. So you have already found out E1. How much is E1? E1 is equal to 2.234. Okay, 2.234. This is equal to ECM. You have calculated ECM here. Okay. ECM has been calculated like this. So let's find out we also know that YC is equal to, you know that in rectangular channel ECM is equal to 1.5 YCM. ECM is equal to 1.5 YCM. So from here you can find out the value of YCM. Okay, from here you can find out the value of YCM. So you can find YCM as YCM is equal to ECM divided by 1.5. ECM divided by 1.5. YCM is equal to ECM divided by 1.5. That is, if you put ECM here, YCM is equal to 2.234 divided by 1.5. Finally, you get the YCM is equal to. Finally, you get a YCM is equal to how much? YCM is equal to 1.489. Okay, 1.489. YCM is equal to 1.489 meter. This is E1 is equal to in meter. Okay, so write this energy in meter. Okay, E1 is equal to 2.234 meter. Okay, this critical energy, we have calculated the critical energy at section 2. Okay, now let's calculate we also know the formula of critical energy, that is YC is equal to Q square by G to power 1 by 3. 1 by 3 in rectangular channel. In rectangular channel. Okay, you can write it YCM, and let's generate a formula, that is Q square divided by B 2M co square into G whole power 1 divided by 3. Okay, whole power 1 divided by 3. And now you can easily find out the value of B2M here. Okay, you can easily find out B2M here. Let's substitute this. Let's say YCM how much? 1.489. 489 is equal to Q square how much? Q is 15 square. 15 square divided by B2M must be calculated square into 9.81 whole power how much? 1 divided by 3. Whole power how much? 1 divided by 3. Now you can easily find out the value of B2M. Okay, you can easily find out the value of B2M by substituting this YCM. How much is B2M? Now we have calculated B2M, that is how much? Is equal to 2.636 meter. 2.636 meter. You can substitute all the data here to get the value of B2M. Okay, B2M 15 square divided by B2M square into 9.81 whole power 1 by 3. So you have calculated B2M. Now let's enter into the cases. Okay, cases. Let's enter into the first case. Okay, first case. What is given here in A? This is B2 is equal to 2.5 meter. Okay, in first case B2 is equal to how much? B2 is equal to 2.5 meter. Okay, now let's compare to this B2M. Here you can see B2 is less than B2M. You can see here B2 is 2.5 meter, B2M is 2.636 meter. B2M is equal to 2.636 meter. Okay, so now here B2 is less than B2M. So B2 is less than B2M, so choking occurs. Okay, and choking occurs. So that means flow is not possible. Flow is not possible in this case. Possible in this case. Flow is not possible in this case. It means there must be energy added from the upstream. The upstream depth must be must be changed in order to make the flow possible, in order to make the flow possible. Okay, B2 is less than B2M, so choking occurs, the upstream depth must be changed in order to make the flow possible. So hence the y1 must become y1 dash in order to make flow possible, okay, in order to make flow possible. Okay, the y1 changes to y1 dash, so that E1 changes to E1 dash. Okay, energy also changes, so that's why you can write the energy equation as E1 dash is equal to EC2, because here critical condition governs less than B2M, so critical condition governs here, so that's why you have to write a different energy equation, that is E1 dash is equal to EC2. E1 dash why? E1 dash the upstream depth changes to Y1 dash, and EC2 why? The critical is governing here, so that's why you write the energy equation E1 dash is equal to EC2. Okay, now let's go to find out the EC2. Okay, now actually let's go to calculate actual case. Actually, how much is Q2 here? Q2 is equal to Q by B2, because B1 is here, B2 is how much? We have added B2 is equal to 2.5 meter, okay? B2 is equal to 2.5 meter, and we compared this B2 with B2M, we compared this B2 is B2M, that is B2M is equal to 2.636. B2M is equal to 2.636 meter. B2M is equal to how much? 2.636 meter, okay? Now we are going to calculate the actual Q2 here. Q how much? Q is equal to 15 divided by B2 is equal to 2.5, and then you are going to get the Q2 how much? 6 meter cube per second per meter. 6 meter cube per second per meter. Now let's go to calculate YC2. Let's go to calculate YC2. How much value YC2? YC2 is equal to actual YC2, Q2 square divided by G. This is a formula for rectangular, 1 by 3. This is actual Q2, this is actual YC2, this is a formula from rectangular channel, okay? Rectangular channel. Now, if you substitute this 6 here, then you are going to get the YC2 is 1.542 meter. 1.542 meter, okay? You have calculated YC2 here. And you can easily calculate the actual EC2 there. That is 1.5 YC2. Let's go to calculate the actual EC2 there. EC2 is 2.3136. 2.3136 meter, okay? You can calculate the YC2. EC2 is 2.3136 meter. Okay, you have calculated critical energy at section 2, that is the actual critical energy at section 2. Okay, now let's go to apply the energy equation, new energy equation, because the depth changes, y1 changes to y1 dash. So new energy equation, that is E1 dash is equal to EC2. E1 dash why? The y1 depth changes to y1 dash. EC2 why? The critical governs there, because the B2 is less than B2M. B2 is less than B2M, so critical depth, critical flow governs there. E1 dash is how much? Y1 dash plus B1 dash square divided by 2G is equal to EC2. We are going to calculate the Y1 dash here, okay? How much depth it changes? How much changes from Y1 to Y1 dash? To calculate the changes from Y1 to Y1 dash, we use the energy equation. Okay? Now let's write B1 dash. B1 dash is equal to B1 dash is equal to Q divided by A1 dash. B1 dash is equal to Q divided by A1 dash, and you can find out the Q divided by A1 dash means B1 into Y1 dash, okay? B1 into Y1 dash, this is 15 divided by B1 means how much? 3.5, the width of 1 is 3.5 into Y1 dash. Okay, you can write like this: v1 dash is equal to q by a1 dash. A1 dash means v1 into y1 dash. Okay, so you can substitute the v1 dash here. y1 dash plus v1 dash means 15 divided by 3.5 into y1 dash whole square into 1 by 2 into 9.81 is equal to EC2. How much is EC2? You have calculated EC2. How much? That is 2.3136. That is 2.3136 meter. Okay. So on solving, you can get the value of y1 dash is, how much is y1 dash? 2.102 meter. y1 dash is equal to 2.102 meter. Okay, this is a new depth of section 1. Okay, already there is a y1 that is 2 meter. It changes to 2.102 meter. There is a changes of 0.102 meter in the upstream depth. Okay, there is a changes of 0.102 meter in the upstream depth. So that's why this is a new depth. The depth must change to y1 dash in order to make the flow possible. Okay, I hope you understood here. Now let's enter into the second case. Second case. Okay, second case means, second case there is a B2 is equal to, how much B2 is equal to, all that are same. B2M is also same. So B2 changes to 2.75 meter. 2.75 meter. Here, this is the second case. Second case, B2M is equal to how much? B2M is equal to 2.636 meter, and B2 is equal to 2.75 meter. Here, B2 is greater than B2M. B2 is greater than B2M. Okay. Now, there is no choking occurs. CHOKING choking occurs. No choking occurs. Flow is possible. Upstream depth need not to be increased. There is no choking occurs. Flow is possible. Upstream depth need not to be increased. There is no need to increase the upstream depth. Okay. Now let's go to find out again actual Q2. Q2 is equal to Q divided by B2. Q how much? 15 divided by B2. B2 means 2.75. And how much is Q2? Actual Q2 how much? 5.4545 meter. 5.4545 meter. 15 divided by 2.75, 5.45 meter. And now let's go to calculate the YC2. Q2 square divided by G2 whole power 1 divided by 3. If you substitute Q2 here, then you are going to get the value of YC2, that is 1.4475 meter. 4475 meter. Okay, this is the YC2. And now Y1 remains same. Y1 remains same in this case. No need to increase the depth to Y1 to Y1 dash. Y1 remains same. But now let's write the new energy equation. Okay, write energy equation in this case. Energy equation means E1 is equal to E2. There is no home petal, so that's why energy equation like this. E1 is equal to E2. How much is E1? E1 is equal to 2.234 meter. 2.234 meter. Y1 is same here in this case. No need to change. Y1 is same. That is 2 meter. And we are going to calculate the value of Y2 plus B2 square by 2G. And how much is B2? B2 is equal to Q divided by A2. Q how much? 15 divided by A2 B into Y2. 15 divided by B2 how much? B2 is equal to 2.75 into Y2. Okay, let's substitute here. 2.234 is equal to Y2 plus 15 divided by 2.75 into Y2 whole square. B2 square. 15 divided by 2.7 Y2 whole square into 1 by 2 into 9.81. If you do like this, on solving, you are going to find the value of Y2 is equal to how much? Y2 is equal to 1.724 meter. 1.724 meter. Okay, if you solve this, then you are going to get the value of Y2 is 1.724 meter. Okay, Now you understand there is no changes in, because no choking occurs, there is no changes in upstream depth in order to make the flow possible. So upstream depth is y1 2 meter and y2 is 1.724 meter. Okay. Now let's conclude this. In second case y1 is equal to how much? 2 meter. Y2 is equal to how much? 1.724 meter. In the width constriction case, there is a depth is decreasing here, 2 meter, 1.724 meter. Okay, this is a water surface elevation, depth of water at section 1 and section 2 in the case of what? In the case of second case of width constriction. Okay. In the first case, let's go to first case. In first case, there is no y1, there is y1 dash. That is how much? Y1 dash is how much? 2.102 meter. 2.102 meter, which is greater than 2 meter. Okay, 2.102 meter. And y2 is how much? Y2 is equal to yc2, because critical energy governs there. In the first case, because there was choking occurs, there was no flow possible. So that's why you can write y2 is equal to yc2. In the first case, that is yc2 is how much? 1.542 meter. 1.542 meter. Okay, this is how the problem is done for the case of width constriction case only. Okay, you have done the case of hump case only and the hump and width constriction combined case, and now this is a width constriction case only. So this is very important problem for final examination. Okay, prepare well and best of luck for the exam. Okay, thank you so much. See you in the next video.